Hi everybody, welcome to another video in Trigonometry, section 2.1, Trigonometric function of an acute angle. So in this section, we'll define trigonometric function for an acute angle, meaning that angle between 0 and 90 degrees. On chapter 1, we define 6 trigonometric functions based on the coordinates x, y, and the distance from that point to the origin r. So x, y, and r earlier. Now, this time we define based on a right triangle, or what we call the right triangle trigonometry. Right. So, if A is an acute angle in the right triangle, so we have an angle A here. Then we have a right angle here. Opposite to that angle is called the opposite. Adjacent to the angle is called the adjacent. The hypotenuse is the longest side, which is opposite to the right angle. Right. So opposite, adjacent, and hypotenuse. Right. So when we define a 6 trig function, the side is going to be opposite over hypotenuse. Cosecant is reciprocal of sine, so we're just going to flip hypotenuse over opposite for cosecant. Cosine is adjacent over hypotenuse. And secant is reciprocal of that. Tangent opposite over adjacent, and cotangent is reciprocal of that, adjacent over opposite. Right. Now, in terms of now, if we write the coordinate based on this, if we write A in the standard position, then the adjacent is going to be x. It's not always, but in this case, angle A is in standard position. Adjacent will be x, opposite is going to be y, and hypotenuse is going to be r. So sine is going to be opposite over hypotenuse, or like y over r. Cosecant is reciprocal of that, r over y. Cosine adjacent over hypotenuse, x over r, reciprocal r over x. Tangent opposite over adjacent, y over x, or x over y for cotangent. So that is consistent to the 6th trigonometric function defined based on x, y, r, but this time we use opposite, hypotenuse, and adjacent. So the idea is, of course, the angle we can rotate anywhere, but the x, y, and r usually is fixed in the standard position, so that's why it's different. And also, if we define using opposite, adjacent, and hypotenuse, there's a few ways to memorize this, and I found this on the internet. So there's a couple of mnemonic to help us to memorize this. Is one of them is this. The old angel sitting on heaven carries a harp. Right. So from there we have tangent, I say of an angle is opposite over adjacent. sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Because that's one of them. The other one is this. Some old hippie got another. Yeah. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Right. So of course that is very consistent with x, y, and r. But this time, because it is defined based on the acute angle, so we define that usually in a triangle, right triangle. Right. Next, find sine, cosine, and tangent of angle A and B for the following triangle, where C is the right angle. So we have C here is the right angle. And if this is A, the other one is going to be B. Right. Now, find sine, cosine, and tangent of angle A and then angle B. Right, so there are two of them. Fold the page in half. Right. Now let's do sine, cosine, and tangent of A first. And then on the other side, sine of B, cosine of B, tangent of B. Right, first, this is the right triangle. We have Pythagorean theorem. This is 5, this is 13. We're going to find this side is going to be B. So, opposite to angle A is sine A, so we have A squared plus B squared is equal to C squared. A is 5 and C is 13. So B squared is 13 squared minus 5 squared. That is 144. 13 square minus 5 square. 13. $144. Right, so B is equal to 12. Square root of 144 is 12. Right. Now, define based on the trigonometry of the right triangle. So, right, now, with respect to angle A, now, with respect to this angle A, opposite is going to be 5. Adjacent is going to be 12. And hypotenuse is still 13. So sine is opposite over hypotenuse. So opposite to angle A is 5. Hypotenuse is 13. So straightforward. Cosine adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent to angle A is 12. And hypotenuse is 13. Yeah, I have to write this smaller, so it's just so that's closer to the camera. Yeah, that's better. And tangent of A is opposite over adjacent. Opposite 5 over adjacent 12. Right, so that is for angle A. That's what we have. Now, with respect to angle B, opposite to angle B is actually going to be 12. So the way we define opposite hypotenuse, opposite and adjacent, is with respect to an angle. So with respect to angle B, 12 is going to be opposite, and 5 is going to be adjacent. So sine is opposite over hypotenuse. Opposite is 12 over hypotenuse 13. Cosine adjacent over hypotenuse. Adjacent to angle B is 5 over 13 the hypotenuse, and tangent of B is opposite over adjacent. Opposite to angle B is 12, and adjacent to angle B is 5. So that's pretty straightforward. Right. Same thing for this example. Sine of A, cosine of A, tangent of A. Sine of B, cosine of B, tangent of B. Right, first we're going to find the hypotenuse in this case, which is C. So A squared plus B squared equal to C squared, because that's the right triangle at C. Right, A is opposite to angle A, so A is going to be 8, and B opposite to angle B is 6. A squared plus 6 squared is 100. So C is square root of that. So in this case, we don't have to worry about the plus or minus, because everything in the right triangle means then that the measurement cannot be negative. So all of them are going to be positive. We're not worried about negative values here. Right. Now, with respect to angle A, 8 is opposite, and 6 is adjacent. And because 10 is still hypotenuse, the longest side doesn't change. So sine is opposite over hypotenuse. Opposite is 8. Hypotenuse is 10. Well, that reduces 4/5. Cosine is adjacent over hypotenuse. Adjacent to angle A is 6 over 10, which reduces to 3/5. Tangent is opposite over adjacent. Opposite to angle A is 8. Adjacent is 6, which gives us 4 over 3. So that is with respect to angle A. Now with respect to angle B, 6 is opposite and 8 is adjacent. So sine is opposite over hypotenuse. Opposite is 6. hypotenuse is 10, so that is 3/5. Cosine of B, adjacent over hypotenuse. Adjacent to angle B is 8, so that's 4/5. And tangent is opposite over adjacent. Opposite to angle B is 6, over adjacent is 8, which is 3/4. Right, so straightforward from the definition. Of course, the triangle can be rotated, it doesn't matter. Opposite or adjacent are defined based on the angle. Hypotenuse is opposite to the right angle, so there's always that. Right. One thing I hope you notice that you see sine of A is equal to cosine of B, and cosine of A is equal to sine of B. It is the fact that with respect to angle A, there's an opposite, and that same sine is adjacent to the angle B. So opposite to this angle is adjacent to the other angle. Because you're switching like that, with the sine of this angle is equal to opposite is cosine of the other angle. By the other angle, I mean the other acute angle. We're not talking about the right angle here. Right. More precisely, we have the cofunction identities. First, we have sine and cosine are cofunction. Secant and cosecant are cofunction. Tangent and cotangent are cofunction. So the reason we define cofunction because there's a co prefix of that, right? So sine, cosine, secant, cosecant, and then tangent, cotangent. Those are cofunction, right? What are the properties? Property says for any acute angle A, sine of A is equal to cosine of 90 minus A. So remember the relation of A and 90 minus A, those are complementary angle. So that is the function of any acute angle is equal to its cofunction values of the complementary angle. By the way, the complementary angle in this sense is extended even more than that just any acute angle. So in general, if A plus B is equal to 90 degrees, then the trig function of A is equal to cofunction of B. So as long as those angles add up to 90 degrees, this function is equal to cofunction of the other. Right, let's see how it works. Right, so express the following values in terms of the cofunctions. Right, so the cofunction of sine is, of course, cosine. And so if we want to go from a function to cofunction, the angle must add up to 90 degrees. So we go from sine to cosine, angle add up to 90 degrees. So we're going to have 90 degrees. Subtract 13. So that's where we can go from an angle to a cofunction. I mean a function to a cofunction. And 90 minus 13, that's 73. Simple enough. Tangent, cofunction of that is cotangent. And if we want to go from a function to a cofunction, it is a complementary angle, meaning subtracted from 90 degrees. Right. So that is cotangent of 23 degrees. Cosecant, cofunction of cosecant is secant, and to go from a function to cofunction, we will have a complementary angle, so subtract them 90 degrees. Like I said, it doesn't matter if the angle is acute or not, as long as they add up to 90 degrees, still work. Doesn't matter if this has to be acute or not. In general, that still work. that gives us secant 90 minus 150, and that minus 25 degrees. Right, so it doesn't have to add up to, it doesn't have to be acute angle as long as they add up to 90 degrees. Right, so simple enough. No, if it is like this, then theta is going to be what? Right. Sorry. Moving on. Find the one values of theta. That's is the solution to this one. So first, cosine 15 is equal to sine of what? Minus 15 degrees. Of course, theta is going to be 90 degrees. Right. But because we go from a function to cofunction, so they have to add up to 90 degrees. So this angle and this angle must add up to 90 degrees. So 15 degree plus theta minus 15 degree. 15 degree cancel out, so theta is equal to 90 degree. Simple enough. Next, tangent of theta is equal to cotangent of theta plus 20 degrees. So it doesn't matter what the value says. If we want to go from a function to cofunction, the angles must add up to 90 degrees. So 2 theta plus 20 degree is 90. So 2 theta 90 minus 20 is 70. So theta is equal to 70 divided by 2, so that's 35. Right, that's simple enough. Right, now let's do some more problem. Suppose the right triangle with the side of length ABC and the right angle is at C. If A is 5 and C is 13, write all the 6 trigonometric function values for A. So let's just draw a right triangle in general, just like that, it doesn't matter. Yeah, it doesn't have to be right scale or anything. Right, so with respect to angle A here, opposite to that is B, angle C is the right angle. Once again, opposite to angle A is sine A, opposite to angle B, sine B, opposite to angle C, sine C. Right, we have little a is 5, C is 13. So first we will find B. After we have A, B, C, find out which one is opposite, adjacent, and hypotenuse, and then we just find the 6 trig function values. Right, so Pythagorean theorem, a square plus b square equal to c square. A square 5, b don't know, c square 13. Actually we just did this, right? So b square, it's 13 square minus 5 square, so that's 144. Yeah, so b is equal to square root of that is 12. Yeah, this is exactly like the first example. Right. But now we define all 6 trig function though. So sine of A, cosine, tangent. Once we have those 3, we have the reciprocal function sine. Reciprocal of that is cosecant. Cosine, reciprocal of that is secant. And reciprocal of tangent is cotangent. right? Now, with respect to angle A, opposite is 5, adjacent is 12, and hypotenuse is 13. So sine opposite over hypotenuse cosine adjacent over hypotenuse, and tangent opposite over adjacent. And now we just flip all of this. 13 over 5, 13 over 2, and 12 over 5. So those are the reciprocal function. What we have earlier, those are co-functions, so the relation are different, except tangent and cotangent. Both of them are reciprocal and they also co-function, but only tangent and cotangent are reciprocal and co-function of each other, right? Tangent, cotangent, and they are reciprocal of each other, right? So up to this point, all we do is find the exact values, use everything based on definition, right? So in chapter 1 we have this definition, and with that we can define special values for 0, 30, 45, 60, and 90 degrees. Those are special values, and the multiple of those values, we can find the exact trig values for those. Now what happens if we have something that is not those values? Then in that case we just have to use a calculator. So for example, very important, if this one in degree, make sure the calculator has to be in degree mode. Hit mode and must be in degree. By the way, on the last problem that we did on section 1.5, I forgot to change the calculator to the default mode. So in that case, you hit zoom number 6, that will go back to the standard window. Zoom number 6, that's the standard window. All right. Now, hit mode and choose degree. That's what we're doing with the angles in degree. So use calculator to find the trig function values for those. So very straightforward, right? So sine of 23.5. Yeah, if it is degree, we don't need to. Just that good enough. And of course, it's just approximation. So we just write a few decimal places. On my MATLAB, make sure that when you type the answer, they will specify how many decimal places we need to have. And then cosine of 15 degree. So to get to degree, minute, second, hit second, apps, that is degree. And don't just hit that. If there's just degree, don't put anything at all. If you use the degree, make sure they have to be the minute. Or you can put 0 second. That's not going to change. Oh, second is to enter second. It could be alpha plus. Right, that's the same thing. But if you just type cosine of 15, degree by itself, it still works. Let's see, if I just want 15 degree, you see, oh, never mind. So that still work. Yeah. What I mean is, sorry, what if I just sine of 23.5 degrees? Yeah, that's still fine. It still works. It doesn't matter. Earlier, I think in section 1. Actually, the first section 1.1, when we take 90 degrees minus that. Let me do that again. If you take 90 degrees minus 23 degree and 5 minutes, let's say, that is correct. If you enter 90 degrees, sorry, second 90 degrees minus 23.5, 23 degree and 5 minutes. No, wait. Okay. All right, let's do this again. See, so that's different. If you calculate in degree mode, it's perfectly fine. See, in degree mode, I do this too again. It doesn't matter where I type the degree or not. If they calculate in degree mode, it's just fine, right? Now, but if the calculator in the radian mode, I do this, which is correct. And when I do this, this is not. Right? So, yeah, by the way, I think there's a bug in the calculator. When they program, they're just missing something there. But what I'm trying to say is very important that when you do the calculation, make sure it's in the right mode. And if we just want 90 degree by itself, I just don't enter the degree. Unless you have minute and second, then you enter degree and minute. I just don't put the degree by itself like this. And also, be mindful with the calculator should be in degree mode. Right, so that's a nice thing about the calculator. Right. So what we have here, 0.96 something. Right. Right. So that's easy, right? Now my question is, on the calculator, it has it has sine, cosine, tangent. What if the question asks you, let's say number 3, how about we evaluate cosecant of 15 degrees? Let's say if it asks you to do that, then what do we have? Remember, we only have sine, cosine, tangent on the calculator. First of all, it must be in the degree mode, the correct mode. And we cannot type cosecant, but we can type the reciprocal. So cosecant is 1 over sine. So just say 1 over sine of 15 degrees. Like I said, if it is in degree mode, it's perfectly fine, but I just type sine of 15. Don't even need to write the unit. Right, so, right, cotangent, then we use 1 over tangent, just like that, right? Now, so from that, we can find the trig values of any measure of the angle, right? It doesn't have to be 30, 45, and 60 when we have those exact values. Here we don't. Right. Next, find an angle between 0 and 90 degrees have the specified function values. Now, if cosine is equal to 0.84432, what is going to be theta? So we find the angle if we know the values. How do we find the angle? Right. So, you see above the sine, cosine, and tangent, there is sine to the negative 1 power, cosine to negative 1, and tangent to negative 1 power. Yes, those later on in chapter 6. Chapter 6, we call those are inverse trigonometric function. But here we just do it now. So theta is going to be cosine inverse of that. So we hit second cosine. Make sure that it is in degree mode, very important. Second cosine of 0.84432. So that's 32.4 degree. Make sure you have the unit for the problem. Next, cosecant is equal to 1.35. Notice that we do not have secant, cosecant, and cotangent in the calculator. The inverse, we don't have that either. So cosecant, we have to rewrite this as the reciprocal function of cosecant is 1 over sine. So cosecant is 1 over sine equal to 1.35. Now we're going to flip both sides. So sine equal to, can write that over 1 and we flip it. So 1 over 1.35. And then we take inverse of that. So sine inverse of 1 over 1.35. Second, sine 1 divided by, and we have 47.79, 0.8 degrees, right? So when we don't have the function, we have to write everything in terms of sine, cosine, and tangent, and then we can use the inverse if we need to. So tangent of 2, the calculator has inverse of tangent, so yes, that's good. So we just say theta equal to tangent inverse of 2. (63.4 degree). Cotangent, we don't have cotangent in a calculator, but we have the reciprocal of that. So 1 over tangent is 0.3 or 0.3 over 1. So we're going to flip that. Tangent is 1 over 0.3, and so theta is equal to tangent inverse of 1 over 0.3. So tangent inverse of 1 over 0.3, 73.3 degrees. Like that, all of those are approximation. Yeah, because all of this numbers is irrational number, meaning that we cannot put them in terms of fraction. Not only irrational number, it's even worse than that. But so we have to stop at some point, and so none of this, just approximation. On the test or on homework, make sure you read the question carefully and use how many decimal places the question will tell you specifically. All right, now we have 2 more examples. A boat attached by a rope at water level is tethered to a dock that is 5 feet above the water. Find the length of the rope. Assume the angle between the rope and the dock is 50 degrees. So let's say we have a boat and it is tethered as the water level. So water level is that, and it is tethered to the dock. The dock is, let's see, right, it's tethered to the dock, and the dock is 5 feet above the water. Yeah, usually that's a bit much. See, the boat is about, okay. Right, and the angle between, this is the rope, and 5 feet above the water, so that is that distance. And find the length of the rope, so we don't know this. And we know the angle between the rope and the dock. The rope and the dock, not between the rope and the water level. So when we talk 50 degrees, actually 50 degrees is going to be this. Yeah, I just assume the dock is kind of like rectangular shape like this. Right, so that's 50 degrees. Right. Yeah, it doesn't make sense. We should say assume that the dock is kind of like a block, like a building. So it's more like that. Right, so we have 5 feet there, and then x. So let's just draw a triangle. So this angle is 50 degrees, and we have 5 feet here, and we don't know, need to know that. So what is x? So in this case, with respect to the 50-degree angle, the 5 here is adjacent to that, right? Adjacent to the 50-degree angle. And x is the longest side, so that's going to be opposite. So we just look for the ratio that have opposite and adjacent. So that could be opposite and adjacent. So that could be sine. I'm sorry. Opposite. So what do we have? I know where the problem at. Sorry. Yeah. X is the hypotenuse. That is the longest side, right? So x is going to be hypotenuse. So the ratio that has hypotenuse adjacent is either cosine or secant. But in terms of calculation, I prefer to use cosine because the calculator has cosine. Calculator doesn't have secant. So we use cosine with respect to the 50-degree angle. We have adjacent, which is 5. And hypotenuse, which is x. Yeah. If you don't want to, we don't need to write it. And cosine is adjacent over hypotenuse. Yeah. Shape of angle A. So adjacent over hypotenuse, so it's that. So it's easy, very easy. Now write that as a ratio, cross multiply. So x times cosine of 50 degree is equal to 5. So x is equal to 5 divide cosine 50 degrees on both sides. So we just have 5 divided by cosine of 50 degrees, and that's 7.78. And the unit is feet. So that makes more sense. It makes sense. It's 5 feet. The rope has to be longer than 5 feet for sure. And 7.78 look reasonable. Right. So usually we just draw the right triangle here and then determine what we have with respect to what angle. And then we just do the math. That's simple enough. Right. Next, we have a building. A 20-foot ladder leans against a building. So let's say we have a building. Okay, ground level. That is the building. The ladder is 25 feet. The building, of course, we assume that's going to be 90-degree angle here. And the foot of the ladder is 4 feet away from the building. So this distance here is 4 feet. What angle to the nearest 10th of degree does the ladder make with the building? So the ladder make with the building, not the ladder make with the ground. So we're asking for this angle. So that angle, let's say this is angle A. So we're asking to find angle A. So with respect to angle A, here we have opposite to angle A, which is 4, and 25 is the longest one, so this is hypotenuse. So we have the ratio that have opposite and hypotenuse. That of course is sine. So sine of A is opposite over hypotenuse. Opposite is 4 feet. Hypotenuse is 25. So that is sine of angle A. To get back to angle A, we'll take the inverse of sine. So sine inverse of 4 divided by 25, and that is 9 point, and this time say to the nearest 10th of the degree, so 9.2 degrees. Yeah. So just draw a right triangle, put in all the information we know, what angle we're talking about here, and then based on the information, the problem, hypotenuse, opposite, and adjacent, we have to use the appropriate trig function. So pretty simple. In this section we only talk about definition of trig function for right triangle. The reason it is for the right triangle because this value is for an acute angle. So we're talking about this angle, that angle. We're not talking about the 90-degree angle, which we know the values. So we only talk about the acute angles. And in the middle of that we have the cofunction identities. Right, but that's all we have for this section. See you in another video in trigonometry. As always, thank you for watching.